Hi everyone, welcome back. We will be solving another lead code today. Apologies for the low volume, quite tired. So let's go to the roadmap. And here as you can see, the next question is valid Sudoku. And we will be solving this question today. It's a medium question because the data structure that we'll be using on this question is quite difficult. So let's go to the question now. So here's the question. As you can see, uh, everything else, let's ignore that. Basically, we have this Sudoku, okay, and we have a list of strings, and every string has the numbers, and the empty cell is depicted as a dot, okay. The empty cell is a dot. Now, you know how Sudoku works, right? I'll just explain it on the whiteboard real quick. So basically, a Sudoku cannot have duplicate elements on the row. So this is no, this is wrong. Duplicate elements on the column, no, wrong. And you cannot have duplicate elements inside this 3 by 3 grid either. So you can't have another 8 here. This is also wrong. So basically we have to verify whether the Sudoku or the string of strings that has been given that depicts the Sudoku, if that is correct or not. You have to check that. Okay. So the data structure that I'll be using to check this is how should I say this? Every row, right? Every row will be the index of the hash set. So how will the hash set work? This this is your set, and every row value, for example, row number 0 will have a set of values here. And this basically will mention that on row number 0 we have we have 5, we have 3, we have 7. Similarly, on row number 1 we have 6, we have 1, we have 9, we have 5. So this is the row hash set. Okay, this is how the row hash set will work. Now, if I were to create the column set, this is, let's say, the column set, and the column set will be like 0 column will have 5, 6, 8, 4, 7. Then one column will have 3, 9, 6, 7. Really, we have other elements. So this is how you know we'll create the data structure. Lastly, to check within this grid, now how will we check the grid? That's quite easy, don't worry. Okay, let me click at this pink. Okay, so let's say the pink part grid. Okay, so if I were to just right there we go. Now, if I were to, let's say, divide the indexes by 3, for example, this is this grid here is 0, 1, 2, and this grid here is 0, 1, 2, right? Um, I let's do one thing. This is a bit confusing, so what I'll do is move this a bit here and down a bit. There we go. Let me quickly fill this up. Now, if we have, let's say, 0, 1, 2, and 0, 1, 2. Okay, how this works is basically I'll have one entry called cell 0, comma 0. Okay, cell 0, comma 0 is this in this cell. Cell comma 0, comma 0 will have items 5, 3, 6, 9, 8. Okay, so cell 0, comma 0 will have these elements. This is how we will be basically creating these grids. Similarly, 1, comma 1. This is the cell 1, comma 1 will have 6, 8, 3, 2. So this is how the cell data will be fed to the data structure. Excuse me. Now, how do we get the grids? If I want the grids, let's see. This is row number 1, 2, 3, 4, 5, 6, 7, 8. Now, if I were to pick any of these indexes from the row or the column, and if I divide them by 3, the question that I get will be the index for the the cell. So this is how it will look. Quite complex, but I understand. So for 3 by 3 is 1. 4 by 3 is 1. So this way, if I let's say 4 3, if I have 8, which is row 4 comma column 3, it will be in 1 1 1 comma 1 cell, which is the cell. As you can see, there you go. That is how I will be adding the data to the, what should I say this, the uh, cell hash set. Let's go and code. So for the code, it's fairly easy. Okay. First, we'll create the row set, call set, and cell set. I'll just quickly get them. There we go. So these are the row set, call set, and cell set. Then for every row in inch 9, because it's given that we have 9, how to say this, 9 9 rows and 9 columns. So if we get dot as the row and column, we just have to continue. Now if just quickly copy this, if there is exists in the row set at row, or this element exists at call set at call, or this element exists at full set yet. So what is it? Row 3, call 3. Then if it already exists, return false. else we will be adding it to the row call set. Row set at this row and this. Similarly, call set at this row at this, and cell set at this row. So cell set at row divided by 3 quotient or call divided by 3, add the element. Return. There we go. If I run this, accepted, and even if I submit, yeah, there we go. The space complexity is high because it's you're using 3 sets as you go see. So I can understand why the space complexity is high, but it's a good solution. Now, if you're curious about how the data will look like in Python, if I were to present, so display or print those hash sets, I'll show you how it will look like. How do I let me quickly reduce the font? There we go. Okay. Okay, nice. So this is the row set. Row number 0 has these elements. Row number 1 has these elements. Row number 2 has these elements. Similarly, this is a curl set. Row number 0 has these elements. Row number 1 has these elements. Row number 4, 0, 1, 4, 3, etc. Okay, 2 here, 2 element, this elements as it. And for the grid, the 0, 0 grid has these elements. 0, 1 grid has these elements. 0, 2 has these elements. And yeah, that's how it works. So this is how you can basically make sure that you are using a hash set data structure to store all the data in the Sudoku. I'll see you in the next one. Bye bye.